Okay, today we're going to talk about scientific notation. So basically, when scientists are talking about different things, if they are talking about things that are really far away, like in the solar system or in the galaxy or even in the universe, it's really complicated to remember all the right zeros. Like, for example, if we had, let's change our color. 396,735,722. That number is really long, right? And without zeros in there, it's kind of easy to make sure that you don't forget things. However, if you have a number like 396 million with lots of zeros on the end, if you forget a zero, it could mean the difference between your spaceship going to the right place or not. So what scientists have decided is that they're going to take a gigantic number like this 396 million and shorten it up. So now we're going to pause with that for just a second. So if we think back to, if I have, let's say 300, let's not even go that big. Let's do 34. Okay, if I did 34 times 10, I would get 340. Okay, if I did 34 times 100, I would get 3,400. If I did 34 times 1,000, I would get 34,000. Okay, and each time I multiply by 10, it gets 10 times bigger, which means in the number pattern we're noticing here is that we're adding a zero each time, right? So times 10 we're adding a zero, times 100 we're adding 2 zeros, times 1,000 we're adding 3 zeros. Now, when scientists are talking about this, our knowledge of powers of 10 are going to be really important. So when we think of times 10, right, we know that over here, that's times 10 to the 1. So 34 times 10 to the first power would be 340. Now, if I change this a little bit, there we go. If I change this and think, okay, 34 times 100, if I look over here, 100 is the same as 10 to the second power, right? So 34 times 10 to the second power. Then if I look at this one times 1,000, 1,000 is equivalent to 10 to the third power. So I can change this to 10 to the third power. So you can see that you can use these powers of 10 to represent larger numbers, right? So what scientists will do is they will often have a number we've got scientific notation starting here. So anytime we're multiplying times these powers of 10, but we're actually not to scientific notation yet. So if we come back up here to our 396 million, now what scientists like is they like to have one digit in the front. So I'm going to actually erase all this other stuff down here to get it out of the way. So if we have 396 million, what scientists like is they only like one number in front of your decimal, okay? So 3.96 or 3 96 times, and we are actually gonna have, and basically we're talking about how far are we moving this decimal? Because if we think about when we were multiplying times 10 to the 2 or 10 to the third, we were adding zeros on the end, right? If I were to take 3 96 times 10 to the first or times 10, I would get 39 6/10. If I were to take 3.96 times 10 to the second, I'm multiplying it times 100, so I would be moving it 2 places. The number 100, if you notice, has 2 zeros here. We're moving it 2 places, so 96. Okay, so then 3.96 or 3 96 times 10 to the third would be 3,960. So if you notice the pattern here, For times 1, we're moving it 1 place. For times 2, we're moving it 1, 2 places. For times 3, we're moving it 1, 2, 3 places. And that little, like little frog jumps. Technically what we're doing is multiplying it times 100 or 1,000, right? But the shortcut or the number pattern here is that we're moving our decimal. So if we have our number 396 million, right? And to get our decimal to right here, we are going to have to, and what I usually do is I start my decimal back here because that's where it is in our whole number. And we're going to backtrack 1, 2, 3, 4, 5, 6, 7, 8. So we're moving our decimal 8 places. So times 10 to the 8th. Okay, so that's how you would take a large number like this and turn it into scientific notation. All right, so this is the same deal. So basically what our formula here is you would have a whole number followed by the other digits that aren't 0 are what go behind your decimal. And then you're going to multiply times 10 to the whatever power. So for example, we have 6 2/10. So let's practice this together. I'm going to do these examples with us. So 6 2/10 times 10 to the 3rd. Okay, so if we're changing from scientific notation to whole numbers, what we're going to think about is, and what I typically do is I write that 6 2/10 over here. Okay, so that's what we're starting with. Now I'm going to go 1, 2, 3 places. That's our exponent up here, and that would be times 1,000, right? So, and then in each of these little dips, we're going to put a 0. So this ends up being, just like it says over here, 6,200. Okay, then if we get a larger number, we have 7. Whoop, goodness gracious. There we go. Sorry, my screen went bonkers. So 7 36/100 times 10 to the 5th. Okay, so I'm going to start by writing 7 36/100. And then I'm going to go 5 places over. So multiplying this times 10 5 times. So each time I move my decimal, it's multiplying it times 10 once, right? So 1, 2, 3, 4, 5. And then again, in each of these dips, I'm going to put a 0. So we end up with 736,000. All right. And sometimes you just have a whole number. So 9 times 10 to the 6th. So once again, we're going to write 9. And with 9, our decimal, if you remember, is right after it because that's our whole number. That's in the ones place. So our decimal lives right after that. Then we are multiplying times 10 to the 6th. So we're going to go 1, 2, 3, 4, 5, 6. And then we need 1, 2, 3, 4, 5, 6 zeros. So we end up with 9 million. All right, one more. So if we have 2 376 thousandths times 10 to the 3rd. So again, we're going to write 2 376 thousandths over here, and then we're going to use our exponent to tell us how we need to change this. So we're going to start at our decimal. We're going to go 1, 2, 3 places because it's to the 3rd, and our answer for that is 2,376. Okay, so that's how to change from scientific notation to our standard notation. Now remember, notation just means how you're writing something. So scientific form or scientific notation into standard form or standard notation. Okay, so now we're going to go from standard notation into scientific notation. So if we think about this, so the sun, my example here is that the sun is 92,960,000 miles away from Earth. So if we wanted to get this, put our decimal here. So because we want it, right? We want it to be, we're going to go from 9296000. Now it's always tricky to not forget those numbers. So 9 and 296 thousandths is our goal, right? That's what we need to get it to. So our question then is, how many times am I multiplying this? So if we were to think about this, we're actually multiplying this decimal number times 10 million, right? And even if we use our estimating skill, 9, if we were to think about this, the 9 is technically in the 10,000ths place, right? So we're multiplying this by 10,000. Okay, so now we're going to take this number and put it into that scientific notation. So 9 and 296 thousandths times 10 to the, and we are taking this from here, 1, 2, 3, 4, 5, 6, 7, to the 7th power. Okay? All right, let's try a smaller number here. So let's start with 87,000. All right, same thing as over here. So 87,000, and we are trying to get it to 8 7/10, right? So now, so our format is always going to be 8 points, or the number times 10 to the something. So we can already kind of set this up here. Then what we can do is, remember our decimals here, we're going to try to move this backwards. So 1, 2, 3, 4, 10 to the 4th. Okay? All right, let's try this one. I'm going to walk you through this one right here. So we have 2,384,000. So our format, as always, is going to be the one number in front of the decimal, so 2 and 384 thousandths, times 10 to the something. We're not sure what the something is yet. So our decimal lives here. We're going to move it back to over here. So 1, 2, 3, 4, 5, 6, times 10 to the 6th power. All right, last one. We are going to have, now it's not always short and sweet like these, 8.7 or 8 7/10. Sometimes, like this one, it's really long, and that's perfectly fine. Sometimes you don't eliminate any numbers, and that it gets really long and kind of a very long decimal. Oop, hang on. 76,320, or 76,324,052. So we're looking for 7.6320.052 times 10 to the something. So we are going to go from here and go backwards till we get our decimal in between the 7 and the 6. 1, 2, 3, 4, 5, 6, 7. So to the 7th power. Okay, so that is scientific. And to kind of look at everything all together. So remember, you have your powers of 10, and that's why we're moving our decimal places either to the left or to the right. We had our scientific notation, and we changed it to our standard notation. And then over here, we had our standard notation, and we changed it to our scientific notation. All right, guys, thanks for listening.